All right, so 21105 was, or number 14 was the one requested to start with. So we've got a 90-watt light bulb, and it offers a potential difference of 85 volts in my case. Is that a 90-watt light bulb? Typical light bulb, or really weird, really powerful, really weak? What? Average. Yeah. Most of the light bulbs that you guys probably use in your household are between 60 and 100 watts. And then your actual system at home, even though it's not a DC system, it can be approximated by a DC voltage of about 110 volts. So this is talking about a typical bulb. So 21105, and I would say the only thing you'd really need in your definition, in your Y here, was power is the rate energy is used, and maybe even showing that you understand current is the rate charge passes through, and maybe, might have in there showing you understand what resistance is, or maybe even voltage. But the big focus on this one would, of course, be power. And then you just go to the equation sheet and grab the different forms of power that you need. P equals IV, or I squared R, or V squared over R. All three of those forms. At this point, hopefully you're familiar with. And then it's really, I hate to say it, but it's a pretty straightforward plug in the numbers they give you, get out the numbers they want. Really no trick to it at all. 90 watts is your power. V is 85 volts. They're asking for the current. So which of those three equations, given that you have the power and the voltage, would you use to find the current? It equals IV. Since it has the other two and it has the third that you're looking for. And then you scroll here. Whoops. Always good to drop the pen before you try to. Then you scroll here and you say, oh, now they want R. Do I have a form of my equation that relates power, voltage, and resistance? P equals V squared over R, and you have the P and the V, and all you're left with is the R. So, and then you just use that same factors to do the bottom part here, where they're asking about this bulb is replaced one whose resistance is half the value found in the previous part. So looking back at our equation, if R is half the value, what's that going to do to the power? Increase. If the number on the bottom of a fraction gets smaller, does that increase the overall value or decrease the overall value? Well, let's think about it. Which is smaller, 1/10 or 1/20? 1/20 is. So, which is smaller, 1/5 or 1/10? 1/10. So what is constantly happening as the number on the bottom gets smaller? The number's getting bigger. All right, so that understanding should get you right to answer C, and then also to answer D. Any questions on this one? Excellent. So number 9's been asked for, which is good because it brings up what you should do on these type. So I'm just getting my parts so I don't have to keep flipping back. So in this, you should do the circuit diagram and also doing the voltages and the currents, the plotting of them. So I'm just going to redraw this. I have a 9-volt battery. So let's see. We'll go like this. Up. Excuse how poorly drawn this ends up being. All right, so 9 volts, R1, 2.5. So then I should label all of those. All right. And of course you would draw all of those. And then I need to do my, well, how many different currents? Huh? I think you could do it. No, not really 6, but which side of my battery is the positive side? The long one. So let's call that I1, and then that would be I2. This would be I3. Here, I'm going to call that I4, and that would also, I4 would also be over here. We'll call this I5, I6, I7 in there, I8, and this coming back out here would again be I5. So 8 different currents. How many junctions? 6 different junctions, and lots of loops, right? I could do 1, 2, 3, 4, 5, 5 that go through the battery. 6, 7, 8, 9, 10, 11, 12 that don't go through the battery. So, lots of loops. Do I need to do them all? No. I only need to come up to enough to have 8 equations. So, let's see. I better do my plot. You guys like the hardest one to plot. Yeah. You could do a little circuit reduction first. Yeah. Yeah, but see if you had it an evaluation on this, you would be required to do all this. So, you know, you could run into a problem like this on the final where you'd be asked to do all this plotting and such. So better to practice it. All of this is at 9 volts. And then all of these are at a lower voltage. And then all the rest are at 0. So, and now I need to label all those. So this would be 9 volts. This in here would be, what's my R1? 2.5 I2. This one in here would be 4.8 I3. Here we would have, oh, wait a minute. Sorry, this was 2.5 also. Whoops. I3. Oh, look at that right away. What do I know about I2 and I3? Right, they have to be the same value. Because they both come down the same 9 volts. And then I would label the rest of these, but I'm getting from most of you that you're not really into it that much, so we'll skip over that labeling, assuming that you have it. Find the current flowing through resistor 1. So I could find all my currents, but resistor 1 for me has I2 in it. And looking at my plot, doing part A, I know the voltage across resistor 1 is 9 volts, so I can just use V equals IR. I've got 9 volts equals I2 times 2.5 ohms. And I'm done. Question B. Potential difference count R6 greater than, less than, or the same as the potential difference across R1. So R6 is this one over here, and I'm going to have to say it's this one down here. I'm going to have to say it's less because some has already been lost going across the parallel section. Look at that, done. So as soon as I finished my plot, I was able to answer all those without really any other work. Cool. All right, so number 7, 21.83 is the next one asked. And they kind of gave you the circuit diagram here, so that'll be nice when we do the plot. And they say a 12-volt battery. So just really need to draw in here. Let's see, I think I'll make my battery go that way this time. And then just up. Resistor. And let's see, what do I have? 12 volts, R, 24, 12 volts, 24 ohms, 7 75 ohms, and 71 ohms. And they want to know the current in the 75 ohm resistor and the current in the R resistor, and then they have some multiple choice parts for you to do. And the current in the 24 ohm resistor. So they basically want to know all the currents involved here. So, again, I would do my plot. Do I need to do the plot, or do you guys have that under control? Yeah. Class says, okay. Enthusiastically. Good. So, I see one junction equation, and I have three currents from reading my problem. And only three currents, so I really need three equations, so I'm going to do my two loops that go through the battery. So, let's see, I set mine up to be I1 equals I2 plus I3, and then I have, I wish this was a little zoomed out, 12 minus 75, I2 minus 24, I1 equals 0, and 12 minus 75, I3 minus 24, I1 equals 0. Oh, not 75, excuse me, 71. Right? Yeah. Right? And let's put those into one of our solves. Let's see. I like the quick math one. So A equals B plus C. 12 minus 75B minus 24C equals 0. 12 minus 70, oops, that's 24C, 24A. Minus 71C minus 24A equals 0. Piece of cake at this point, right? A, B, C. I can say approximate 4 digits. Solve this button. And I get this. And of course, once I have those, I have A is I1, B is I2, C is I3. They asked me for I1, I2, and I3. So, yay. All right, so 2184 asks us to find the net resistance. So, let me grab a picture of that so I don't have to redraw it. Really, your Y for this is going to be your circuit diagrams as you work down. So, for 2184, they tell me my R is 44 ohms. So remember, the rule is I can only combine resistors that are either in series or in parallel with each other. So in this first circuit, I've got two resistors that are in series with each other, so I can combine those, and I'll end up with a single resistor that'll then be in series with my 24 ohm resistor. And then I can combine those two resistors since they're in series, and I'll be down to a single or equivalent resistance for the points between A and B, and thus my job is done. So for the first part, to combine those two resistors that are in parallel, I'm going to use 1 over R total equals 1 over R1 plus 1 over R2, or 1 over R total equals 1 over 75 plus 1 over 44, and therefore my R total in that case, that'd be good if I had my calculator out. Remember, this is where your inverse key is your best friend. Thank you, sir. Huh? I don't know why I keep missing it. That's what I'm using. That's what I'm using, yeah. And as Adam told me, it is 27.73 ohms for me. And then I have 2 in series, so I'm going to use that R total is R1 plus R2 for those series ones. And get a final answer of 51.7 ohms. And that'll be my final equivalent resistance. I added the 2 together that were in series. All right, I'm going to stop here so I can save this and post it before the block ends in a couple of minutes.